All right, guys, welcome to 2.1. This is a review section, so this is not something that you definitely need to watch, but it is, since it's review, it does cover, uh, in this case, section 2.1 is over integers and scientific notation, integer exponents and scientific notation. And so if you are weak in your rules for exponents, then you definitely want to work through some of these problems. Okay. Now, what we do here is we are going to, you can basically split up your exponent rules into three different types. So I'm going to highlight. So we have the negative exponent and our zero exponent rules. So that's one type. And then we have multiplying like bases and dividing like bases. That's the second type. And then we have the last one, which includes the power rule, the power of a product, and the power of a quotient. And so it's like the more rules that are added to all of this, then the more involved your problem can be. Okay. But we're going to take this step by step. Now, the first thing that I want to point out is let's look at your negative exponent rule. Your negative exponent rule says that if you have a base raised to a negative exponent, now I can make this a fraction and put it over 1. Now notice, now we cannot leave our answers with negative exponents, okay? So if you have a base raised to a negative exponent, then just take the reciprocal and notice that when your b to the minus a, that negative exponent, when it comes down to the denominator, notice how it's positive, okay? Well, so here is a nutshell rule. If you have a negative exponent that's in the numerator, then you move it to the denominator, okay? And the same holds is if we have a negative exponent in the denominator, then I can bring this up into the numerator and it makes my exponent positive, okay? Now, your zero exponent rule says if your exponent, whatever, if you have a zero exponent, then whatever base it's touching, that's 1. Now, the key thing here is you always have to ask yourself, what is the exponent touching? Okay. So let's look at number 1. So I see that we have this, let me spread this out a little bit. So we have this negative exponent. It's in the top, it's in a numerator. Okay, so the way that I'm going to handle this is I'm just going to throw it to the denominator, and this is going to give me x over y squared. And that's it. That's all you have to do. Okay, it's really easy. Now, number 2, you have a negative exponent in the bottom. And like I said, wherever your exponent is negative, you move it. So this means this is going to come to the top. So we're going to have a times b to the positive third power. All right. Now, remember I told you, always ask yourself, what is the exponent touching? So this negative 1 exponent, and let me rewrite this and space this out just a little bit. So this x to the minus 1 is on the negative 1 exponent is only touching the x. So that's what I need to move. Since it's in the numerator, I'm just going to move it down to the bottom, and that becomes a positive 1 exponent. So it's just negative 2 over x. Okay. Now, number 5, we get into our 0 exponent. So again, what is the exponent touching? Well, it's only touching the z. It's not touching 5z. It's only touching the z. So this is going to become 5. Now, any base raised to the 0 power is a 1. That's what my rule says. A base to the 0 power is just 1. So 5 times 1 just simplifies to 5. Okay. Now, number 5 is different because look at the difference between 4 and 5. In 4, the 0 exponent is only touching the z. Excuse me. But in 5, the 0 exponent is touching all of it. Okay. So since that's the case, this is just going to be a 1. All right. So that one can be tricky. So you got to be really careful with that. All right. Now, number 6, they throw both of those in. We have a 0 exponent as well as a negative exponent. Okay, well, 8 times w to the 0, that's just going to be a 1. And then I have this y to the minus 6, which is going to go down to the denominator as a positive exponent. And so we're going to end up with 8 over y to the 6th. Okay. Okay, now let's look at number 7. Again, what is the exponent touching? Is it touching the negative 8 or is it only touching the 8? And for number 7, it's only touching the 8. So what we can do is we can pull the minus sign away and have minus 1 times 8 squared. So here's the minus 1. 8 squared is 64. Then minus 1 times 64 is minus 64. Okay. Now, number 8, the exponent is touching all of it, the negative 8. So this means negative 8 times negative 8, which is a positive 64. Okay. So you have to be careful whenever you see this. Now, real quick, 7 always confuses people. So let's see, I need some room. Let me do this down here. So let me put a little asterisk by number 7 because I want to show you something real quick. And I'm just going to squeeze this in down here at the bottom. Okay, so if we were to have 3 squared minus 2 squared, and we were to simplify this, well, the first thing that you would do is you would take 3 squared, which is 9, minus 2 squared, which is 4, and then that would give you a positive 5. Okay, now notice, if I were to cover this part up, do you see how the negative sign still stays there? And the only thing that we did was square the 2. We did not square a negative 2. Okay, so something like number 7 is just taking that back half of that example that I just showed you. So again, always ask yourself, what is the exponent touching? Is it only touching the base or is it touching all of it? Excuse me, guys. Okay, now for number 9 and 10, you actually luck out because both of these are going to end up being the same answer. So again, here, the 3 exponent is only touching the 3. So this is negative 1 times 3 to the 3rd. So negative 1 times 27, which is negative 27. And then number 10, the 3 exponent is touching my base of negative 3. So that means I have negative 3 times negative 3 times negative 3. And again, that's going to give me a negative 27. So you luck out when your exponent is odd. But when it's even, you have to be very, very careful. Okay. All right. Now, number 11, Earlier, we were dealing with when we had a negative exponent, it was the negative exponent and our base was a variable. Well, your base could be a number, but the same thing still applies, okay? So this is going to move to the denominator. So we're going to have 6 over 3 squared, which is 6/9. We can reduce the top and bottom by 3 to get 2/3. Okay? All right. Now for number 12, this is where we get into multiplying like bases. So when your base is the same and you're multiplying, then you add your exponents. Okay? So here's what we're going to do. So I'm just going to take my exponent, and we have 5 plus a -8 plus a 1, and that's going to give us -3 plus 1, that's -2. Okay. So what this means is now we're going to take our base, which is the x. Our new exponent is a -2. But again, it's a negative exponent, so I'm going to move it. It has to go to the denominator. So if it goes to the bottom, then what's left in top? Well, if all you had was that one term and it moved, then you're left with the 1. Remember, I told you you can put it over 1 and make it a fraction, then take the reciprocal, flip it, and so that's why the 1 goes at the top. Okay? All right, now number 13, we have this -5 squared times y to the -3 times y to the 5th. Okay, so first I'm going to go ahead and deal with my exponents. So our exponent is -3 plus 5, which gives us a +2. All right, so let me rewrite this. So now we have a -5 squared times y squared. Okay, so positive exponents everywhere, so I'm not going to be moving anything. Okay, now be careful because we have a -5 squared. Now, what is the exponent touching? It's only touching the 5, not the -5. So this is -1 times 5 squared times y squared. So this is -1 times 25y squared, which makes this -25y squared. Okay? All right. Now, for number 14, you can do this one of two ways. Now, the way that when you have positive exponents like this, the way that I like to present this is if you notice your A's, you have more A's in the bottom than you do in the top. And for the B's, you have more B's in the top than you do in the bottom. So for the A's, well, how many more A's do you have in the bottom than in the top? Well, you have 1 more A in the bottom than you do in the top. For the B's, how many more B's do you have in the top than in the bottom? And you have 6. So that just simplifies to B to the 6th over A. Okay, now, if we did this, how I had previously showed you, so we're going to have the A exponent. So that means we're going to have a 5. Now, since the way that we handle this is if you'll look at your like division of like bases, notice that the rule says that you keep the base, but you subtract the exponent. So it's the top minus the bottom. Okay. So that means for the 5, we're going to get 5 minus 6, which is a -1. And then for the B exponent, then top minus the bottom, which gives us a 6. So if I were to rewrite this, I would get a to the -1 and b to the 6th power. Notice that you have this -1 exponent, so that means it's going to have to move to the bottom. So we have b to the 6th over a. Now, I don't care which way you do it. To me, it makes a little bit more sense that if you think about it, if it's top heavy or bottom heavy, leave your remainders where they are. Now, for 15, this one's a little bit tricky because we've got a whole lot of stuff that's more involved, okay? So I noticed that my C's, the exponent on my C's are positive, so I'm okay. So what I think I'm going to do first is I'm going to go ahead and deal with those negative exponents. Since they, for the D, now since they are both negative, if it's negative in the top, then it has to move to the bottom. If it's negative in the bottom, then it has to move to the top. So this is going to give me D to the 3rd, and then we're going to bring, the D to the 5th up top. Okay, now look at where you are. Look at what's top heavy and bottom heavy. So first of all, 12 over 18. I can reduce the top and bottom by 6. So that's going to give me a 2 and then a 3. Okay, now for my C's, I have 1 C in the top, 4 C's in the bottom. So I have more C's in the bottom, and I have 3 more C's in the bottom than I do in the top. All right. Now for the D's, we have D to the 5th over D to the 3rd. You have more D's in the top. So we have 2 more D's in the top than in the bottom. And that's it. Okay. Now, when we get into this last part, we start to talk about our power rules. So let's look at our power rules real quick. So our basic power rule says that if I have an exponent raised to another exponent, so a power raised to a power, I multiply the exponents. That's my most basic power rule. Okay. Then when I have the power of a product means you're multiplying 2 things together and you have this outside exponent. Well, that means everything inside has to get the outside exponent. So a to the m times b to the m. And the same thing holds for the power of a quotient. Again, the only difference between these two is here you're multiplying and here you're dividing, but the same rule applies. So if you're dividing and all of that is raised to an outside exponent, well, everything inside gets the exponent. Okay, so let's look at number 16. Now, it might make more sense for number 16 to go ahead and pull your like terms together. So in other words, I'm going to pull my numbers, -3, and an 8 times x squared times x to the -2 times y to the 5th. Okay. Now, we're going to clean this up. Now, the reason why I could do this is because I'm multiplying all that stuff together. So 3 times -8 is -24. Okay, now look, you're multiplying like bases, so you add your exponents, so keep the base. So 2 plus a -2, and then your y's is going to be y raised to the 1 plus 5 power. Okay, well, x, now our new exponent, 2 plus a -2 is a 0. And then y, 1 plus 5 is 6. Well, what is x to the 0? Remember, that's just 1. So we can just kind of disregard that. So this is going to give us negative 24x y to the sixth. Okay. All right. Now 17. So we have this outside exponent of the negative 2. So, and then inside, we are multiplying x to the negative 3 times y to the fourth. And that is your power of a product. Okay. So when I have the power of a product, I distribute the outside exponent. All right. So this is going to give me x to the negative third power, but I have to raise this to the negative 2 power times y to the fourth power, and I'm going to raise this to the negative 2 power. Okay, now we're going to clean this up. Now we have to jump back to another rule, which is the first power rule, which says that when you have a power raised to another power, you multiply your exponents. Okay, so negative 3 times negative 2, well, that gives us a positive 6. And then 4 times negative 2, that's a negative 8. We have a negative exponent, and that's going to have to go down to the bottom. So x to the sixth over y to the eighth. Now, that's not the only way that you could have solved it. You could have moved your x to the minus 3 to the bottom here and then distributed that negative 2 exponent. But then that would have been, it actually would have been worse if we did that. There would have been a whole lot more steps involved. Okay, let's look at number 9. So we have several things that we're multiplying inside, and it's all being raised to the second power. So this exponent has to get attached to everything inside. Okay, so be very careful. So we have a negative 4 that we're going to square. We have a b to the negative 3 power that we're going to square. And then we have a, oh, I'm sorry, that's an a. So an a to the negative 3 power that we're going to square. And then we have a b to the 10th that we're going to square. Okay, so now the first part, negative 4 quantity squared. So I have two negative 4s that I'm going to multiply. So negative 4 times negative 4 is a positive 16. Now a to the negative 3 squared, you multiply your exponents. So that's a to the minus 6 times b to the, well, 10 times 2 is 20. We have a negative exponent, so that means it's going to have to move to the bottom. And there you go. All right. Now, number 20 almost looks like something like number 16. Because we have two binomials, right? Except this binomial is being squared. So the first thing that I have to do is take care of this binomial that's being squared. So remember, this outside exponent gets attached to everything inside, the 3, the x, and the y. So we're going to have 3 squared times x squared times y squared. So let's clean this up. So 7x squared y to the minus 6. This is going to give us 9x squared y squared. Okay, now I'm back to what I had in number 16. So we're going to pull our numbers together, 7 times 9. We're going to pull our variables together, x squared times x squared. And then we're going to pull the y's, y to the minus 6 times y squared. Okay, so 7 times 9 is 63. When you multiply like bases, you add the exponent. So 2 plus 2 is 4. Then for the y, add them. Minus 6 plus 2 is a negative 4. So we have a negative exponent on the y. So the y is going to go down to the bottom with the positive 4 exponent. Okay. Now, these exponent rules can definitely get tricky. All right. Okay, now let's look at scientific notation. So scientific notation is a number expressed in the form of a times 10 to the n, where n is an integer in between 1 but less than 10. Oops, sorry. So a number expressed in the form a times 10 to the n, where n is an integer, counting number, could be positive or negative. Okay. A, so this number has to be a number in between 1 but less than 10. All right. So the way that we do this is to write a number in scientific notation. The number of positions that a decimal point must be moved determines the power of 10. Numbers of 10 or greater require positive exponent on the 10. Numbers between 0 and 1 require a negative exponent. Okay, so here's what they're saying. So first, we have this large number. So if you have a large number, that means your exponent is going to have a positive, it'll be positive. Okay, so let me just write this. So large numbers will have a positive exponent. Okay. Small numbers will have a negative exponent. And when we say small numbers, we're talking about numbers less than 1 but greater than 0. Okay, so those are decimals. All right, so here's the way this is going to work. So first, I want to know where my decimal is on number 21. So my decimal is right here. Now, I need to turn this number to where I get a number in between 1 and less than 10. So in order to do that, I would have to move my decimal move the decimal 6 places to the left. So 1, 2, 3, 4, 5, 6. So now I'm at 5 point something. Well, 5 is a number that's in between 1 and less than 10. So here's the way this works. It's going to be 5 point, actually, let me not do this part. So this is going to be 5.0 times 10 to the, and how many places did we move? We moved it 6 places. And that's the scientific notation for 5 million. Okay. Now, 22, here's your decimal. I need to move it to where I get a number in between 1 and less than 10. Well, if I move it and I land right here in front of the 1, that's 0.12. Well, that's less than 1. And if I move it over here behind the 2, that's 12, which is bigger than 10. So it has to go in between the 1 and the 2. So we moved it 1, 2, 3, 4, 5. Hang on. 1, 2, 3, 4, 5, 6. So we moved the decimal 6 places to the right. Now, this is a small number, which means your exponent is going to be negative. So we're going to have 1.2 times 10 to the minus 6 power. And that's what we mean by when you have a large number, okay, you're going to have a positive exponent. When you have a small number, it's going to be negative, right? Number 23, we have the number 234. So here's my decimal. So I need to move it to where I get a number in between 1 and less than 10. So I'm going to move the decimal two places. Now, this is a large number because it's bigger than 1. So this is going to turn into 2.34 times 10 to the second power. Oops. Okay. All right, now we're going to go the other way. Now I'm going to give you scientific notation, and we're going to turn this into decimal form. All right, so I noticed that 4.83 times 10 to the fourth. So this tells me how many places I'm going to move my decimal. So I'm going to move 4 places to, I need this number to get bigger. It's a positive exponent, which means I'm going to have a big number. The only way I get a big number is if I move it to the right. Okay, so we start off with 4.83, 4 decimal places. 1, 2, 3, 4. Now, these empty slots, I fill in with zeros. So my number is going to be 48300. So this is 48,300. And you can count back. Here's your decimal. So if you count back 4 places to the left, 1, 2, 3, 4, you're at 4.83, which is where you started. Okay. All right. Now here we have a negative exponent. So we're going to move left 4 places, because the negative exponent means my number has to be small. Okay, so if we start off with 4.83, I have to move 4 places to the left. So there's 1, 2, 3, 4, and this is where my decimal will land, right? So I'm going to fill in those zeros. So we're going to have 0.000483. And this is my number. Now, people always ask, do you have to put this first 0 in front of the decimal? No, but it's good manners. Okay, it's like good manners. It's proper for you to do that. Okay. All right, 26. 5 times 10 to the minus 6 power. So my exponent is negative, which means this number needs to be small. So I'm going to have to move left, move it to the left 6 places. So if we start off with 5.0, well, there's 1, 2, 3, 4, 5, 6. That's where my new decimal goes. And then we're going to fill in all these zeros. So my answer is going to be 0.000005. Okay. All right. Now, you're going to need your calculator for this. And where did my calculator go? Okay. Hang on a second. Okay, so what we're going to do here So when you multiply numbers that are in scientific notation, so remember, you're multiplying everything 2.3 times 10 to the fourth times 8.8 times 10 squared. So all of it's being multiplied. So what we can do is we can take the 2.3 times 8.8 times the 10 to the fourth times 10 squared. Okay, so let's go ahead and multiply this. So 2.3 times 8.8 should give you 20.24 times, well, notice your bases are the same, and so you add your exponents. 4 plus 2 is 6. Now, it would be nice to think that we're done. However, look at your first number. It's 20.24. Remember, scientific notation, your A has to be a number that's in between 1 and 10. Okay, so this is going to turn into 2.024 times 10 to the first power times 10 to the sixth. Okay, so if you're unsure about this, then take 2 point, come on, take 2.024 times 10, and that's going to give you 20.24. Okay, so that's how you know you're right. All right, so now we have 2.24 times 10 to the, well, 1 plus 6 is 7, and there you go. There's your answer. Okay, now when you divide, we're going to do the same thing. So we're just going to split this up and say 4.8 divided by 8.0 times 10 to the sixth over 10 to the eighth. Okay, so now go ahead and divide 4.8 times, or 4.8 divided by 8 is going to give us 0.6 times 10 to the, well, here you're going to have to remember your exponent rule, which is top minus the bottom. So that's 10 to the minus 2 power. And again, it would be nice if we were done with this, but we're not, because remember, your A has to be a number that's in between 1 but less than 10. So I have to move this over. So this is going to be 6 times 10 to the minus 1 power times 10 to the minus 2 power. And then again, if you're in doubt, then just double check that. 6 times 10 raised to the minus 1 power okay, 6 times 10 to the minus 1 power does give me 0.6. So now we're going to have 6 times 10 to the, well, add your exponents, and that's to the negative third power. Okay. All right. Now 29, you have a word problem. So it says, in 2016, the population of Tokyo, Japan was approximately 13.62 million people. If the city of Tokyo covers approximately 8.45 times 10 square miles, what's the population density per square miles? Okay, so what we have to do is, this is not, this part is the scientific notation part. So this actually means 13.62 times 10 to the 6. Now, how do I know to the 6? Well, million. So 1, 2, 3, comma, that's 1,000. And then another 1.3, comma, that's million. Okay, so 6 zeros. So that's why we have this 13.62 Okay. Now we're going to leave it alone because we're going to adjust it in a minute. So here's what we're going to do. It says if the city of Tokyo covers approximately 8.45 times 10 square miles, what is the population density per square miles? So the population density per square miles means they want to know what is the amount of people per square mile. So our population is the 13.62 times 10 to the sixth. And then we're going to divide that by the square miles, which is 8.45 times 10 squared. Okay, so let's number crunch this. So 13.62 divided by 8.45. Now we're going to have to round. Let's round to the nearest tenth. So that means this is going to be an approximation. So 1.6 times, well, look at your tens. You have more tens in the top than you do in the bottom. So we have 4 more tens in the top than in the bottom. Okay. So that means our population density is going to be 1.6 times 10 to the fourth people per square mile. Now, how many people is that? Well, this, move it 4 places over. So 1, 2, 3, 4. So that's going to be 16,000 people per square mile. And that is a lot of people to squeeze in a small area. Okay. All right. So that's it for exponents and scientific notation.